Hello class, happy Friday. I got all your from Wednesday, so thank you guys for watching the video, doing some practice. I got some feedback in terms of writing a little bit more clear and separating sort of the questions in the video, so I'm going to put this into two different assignments. So after this lecture you'll do some practice, but if you mess up or you need to try again, you'll have to redo the responses for this one again. So keep that in mind as you do this, that you'll have some time to practice afterwards. You can have unlimited attempts, you could work together. It's really meant to be practice and to figure out like what the answer is. So this one's about chain rule, and in your notes, I'm not going to talk about why the chain rule works. It's something that you should have learned last year. Again, most of this stuff is supposed to be like refresher. This is sort of like the basics, and I know the stuff that you really want to practice is the word problems. So if I move on down to the chain rule, if you forgot what the chain rule is if I take a derivative of a function that's inside of a function, you take the derivative of the outside function, leave the inside function alone, and multiply that by the derivative of the inside function. Okay. So if I scroll down to the first example, here is a function. X squared plus 5x minus 3 is a function. It's actually nested inside of another function. This parentheses like raise it to the fourth power. So there are two functions here, one on the inside and one on the outside. If I follow the basics, the tenets of the chain rule, what I'm going to do is first I'm going to take the derivative of the outside. So if I real quickly, I'm going to solve for y prime, and I'm using a different program, so if it doesn't work out, just let me know, but it's supposed to be a little bit clearer. And since my outside function is to the fourth power, or raised to the fourth power, I'm going to use the power rule for this outside function. So just think of this as like, disappeared for a second, and my function is parentheses to the fourth power. And what is the derivative of parentheses to the fourth power? Well, the derivative is 4 parentheses, and then, the stuff that's in the parentheses, to the third power. Do you see how I took the derivative of the outside function? So this is the outside right here, parentheses to the 4. And I just did power rule. I put 4 out in front and made this a 3. The inside stayed the same. And then the second rule of chain rule is multiply by the derivative of the inside function. So my inside function is x squared plus 5x minus 3. And using the power rule in there also, you'll know that my derivative is 2x plus 5. And that's really all you need to do for the chain rule. If I had any other coefficients, I would combine them and move them out in front. But really, this is already as simplified as it needs to be. Okay. And the second one, and if it's okay, I'm going to delete. I'll delete this work right here. And if you need to copy it down, you can delete it. You can pause the video. Looking at the second function over here, you may notice that it's 2 cosine 4x to the third. One rule that you may or may not know, I didn't teach it, and hopefully you guys know, if you have a coefficient out in front, technically one of the rules that you could do is sort of move it to the side for a second. It's one of the rules of derivatives, and also for antiderivatives. So this 2, just for a second, imagine I'm just going to put it to the side for now. Like I'll finish the derivative and I'll put my factored coefficient back in later. So really this, I'm going to find the derivative of cosine 4x to the third. You may not know what the outside function is here, but there should be an invisible, and maybe you may or may not know this, but this is technically cosine parentheses 4x to the third. My outside function is cosine, and my inside function is 4x to the third. So let's apply the chain rule. The outside function is cosine, so its derivative is negative sine, and I'll leave the inside parentheses alone. I just took the derivative of the outside function. I then multiply by the inside function, derivative of the inside function. My inside function is 4x to the third, so its derivative is 12x squared. And then, different from this problem, everything was sort of simplified already. In this case, my coefficient is here on the outside, or on the right, where it's usually located in front. The answer is going to be negative 12x squared sine 4x to the third. Again, I'm just rearranging the terms. Now, before I box this and say this is my answer, remember at the beginning of the problem, I sort of moved away the 2. Like I'm supposed to, there's this multiplier of 2, this coefficient of 2. Now that I'm actually finished with the derivative, I'm going to bring that 2 back and multiply my final answer by 2. So the chain rule derivative of this particular function is negative 24 x squared sine parentheses 4x to the third power. So that is the derivative of this function. This third example over here, same thing as the first problem. My outside function is a parentheses to the power. So you'll be like, oh, that's really easy. That's 5, 1 over 5x squared, because the parentheses sort of, it does stay the same. And my power rule, 5 goes out in front, and I subtracted 1. That's how I got 4. Now I gotta take the derivative of the inside function. And you may notice something. My inside function is a quotient. It's a term divided by another term. I have to use the quotient rule. So let's try the quotient rule. I'll take the derivative of the first one. The derivative of the first one, you may notice, is 0. And I'll leave the second one alone. And I would write parentheses 5x squared minus 7, but you know, you're all so smart that if I multiply by 0 anyway, it's just going to end up 0. In the quotient rule, there's a minus. Then I leave the first one alone and multiply by the derivative of the second one. In this one, 5x squared minus 7, my derivative is 10x. And then you may remember at the tail end of the quotient rule, it's all over the denominator squared. So 5x squared minus 7 squared. It's messy. It's not supposed to be, very neat. But to organize it, my final answer, how it should look like, is 1 over 5x squared minus 7 to the fourth. I'll sort of remove that multiplication sign. This top one, 0 minus 1 times 10x, will just be a minus 10x. And then the denominator will just stay. So anyway, long story short, this is combining two different rules, the chain rule and the quotient rule, all in the same problem. And the last problem in this set, let me delete this work. Again, if you could pause it if you needed to copy it down. Looks like a different type of problem. In this problem, there is a chain rule template or a chain rule type that you've seen before, parentheses and then something on the inside. But the problem is that it's not the overarching, the big function in this one is not the chain rule. Actually, the big outside function is actually a quotient rule. This chain rule is actually inside of a fraction. So instead of doing chain rule first, this problem I actually have to do the quotient rule first. So I'll take the derivative of the first one, and you may notice the first one is a chain rule. So we have a problem where the denominator is a chain rule and the numerator is a chain rule, and it's inside a quotient rule. Yeah, okay, fine. It's not that fun, but it's interesting. So what I'm going to do is I'm going to take the derivative of the top one first. It's a chain rule. Remember with these sine and cosines, there's these invisible parentheses. So this is technically sine of 3x. I'll take the derivative of the outside, which is cosine 3x, times the derivative of the inside. And you may notice that the derivative of the inside is just 3. So because it's 3, instead of doing dot 3 out here, I already know 3 is a coefficient, so I'm going to leave it out in front right here. Leave the second one alone. So the second one is 2x plus 5 to the fourth power. Minus, leave the first one alone, times the derivative of the second one. And you may notice, and we've done a lot of examples of this already, the second one is a chain rule. So what I'm going to do is I'm going to put the 4 out in front, leave the parentheses alone to the third power. And then, running out of space here laterally, times the derivative of the inside, which in this case is just 2. And this is all over the denominator squared. So if I squared this bottom, it would actually be 2x plus 5 to the 8th power, because 4 times 2, like if I square this to the 4th power, now becomes to the 8th power. There are some things you could simplify here. Technically, I could multiply this 4 and 2, and this could be 8 sine 3x parentheses to the third power. But I'm running out of space here, and you sort of get the point, so we'll leave it like this for now. Now, to make it slightly more difficult, okay, and here's some examples, and I think you sort of get the point, so I'm not going to go over that too much. But one thing I do want to go over, this is the last two that I want to do for this lesson, is what if you have the chain rule more than once? Well, it's like the derivative of the outside, then you're going to leave the inside alone. then the derivative of the inside, basically you're doing the same step over and over and over again. So this one actually confuses a lot of my previous students. You have this cosine 5 here in the middle. What this really means, because it's really confusing to some people, is I will rewrite it. That means the exact same thing as this. And which is also confusing, because remember this cosine 3x, people don't know what that means. So what I'm going to do is I'm going to add that parentheses also. So you may not notice this, but I have 3 functions. I have a parentheses to the 5th power, that's function number 1. I have this cosine, which is function number 2. And then I have 3x, which is function number 3. Chain rule, basically I'm going to work my way outside and all the way inside. My outside function is parentheses to the 5th power. So let's write the derivative of the outside function. 5 parentheses cosine, and I'll leave the inside parentheses alone, right? And I'll raise it to the 4th power. Times the derivative of the inside. My inside function is cosine 3x. So the derivative of cosine is negative sine, and I'll leave my parentheses alone. Then this particular chain rule also has a parentheses inside it, so the derivative of the inside of this function is 3. So to put it all together, to string it all together, make it all nice and neat, I'm going to put this 3 times it by a negative, times it by this 5, sort of combine all these coefficients together out in front, and then it's going to be cosine, and what this means now, like this number in the middle actually means parentheses, the whole thing 5, so I'm going to stick the 4 back in the middle, cosine to the 4th power, 3x, and then also multiplying that by sine 3x. So that is how you do the chain rule for multiple functions. Okay, and then one last one. Again, I'm going to delete this right now. If you need to copy it down, you could pause me. So just going to delete this real quick. This second function, you may notice that there's a radical. We haven't done any radicals before, which is not very radical. Ha ha ha. All right, here you go. I don't have a rule for radicals. What I do have a rule for is power rule and exponent. So I'm going to convert this whole thing into an exponent. I'm going to rewrite this problem as sine x squared to the 1/2 power. So this whole thing, instead of saying square roots, I could write to the 1/2 power. So now let's do our chain rule. I got 3 functions again. I got a half, I got a sine, I got an x squared. So let's do outside, working our way in. Outside, half, inside, sine x squared, and then to the negative 1/2 power. That is the derivative of the outside function. Times the derivative of the inside function. The inside function next is sine, and that's derivative is cosine. And then this itself has its own parentheses times the derivative of x squared, which is 2x. Putting these all together and making it nice and neat, what I can do is I can put this 2x in half and combine them together. 2x divided by 2, or 2x times half, is just x. So what I can write is x, parentheses, sine x squared to the negative 1/2, cosine x squared. So there you have it. That's the chain rule. It's supposed to be a review, so if I went really quickly, I could help you, one-on-one, or I could help tutor you. But ultimately, you're taking the derivative of the outside, leave the inside alone, and multiplying the derivative of the inside. So what you're going to do now is you're going to practice. Again, don't be stressed out about it. It's supposed to be practice. Worst case scenario, you could put random values and they'll tell you what the answers are, but you're not going to really learn. So please take the practice seriously. Hope you guys have an awesome, great, safe weekend. Many prayers to you and your families. And I will see you on Monday. Take care and be good.